Well, good morning, everyone. My name is Frank Pedro. I am here on behalf of the FRDA, which is the Florida Roof Deck Association. We're an association of the lightweight insulating concrete roof deck applicators here in the state of Florida. This association has been around. It was started in the early 90s, I want to say, after Hurricane Andrew as the South Florida Building Code by the local applicators in South Florida in an effort to actually write the building code and represent the industry when all the code changes and everything were happening. And then as the industry grew as we had more companies, it turned into the Florida Roof Deck Association, encompassing more companies from across the state. It's basically a bunch of competitors that got together to make sure we can all keep fighting against each other. I mean, I guess that's probably the most real way to say it, but I consider everybody colleagues. So here we go. Again, like I said earlier, my name is Frank. I work with a company called Cellucrete. I've been doing this for 30 years. Yeah, since 1995. So we're coming right up on 30 years. Mainly because I can't find another job somewhere else. But here we are, and it's been a blessing, and God has been good to me, and this has been a career. So we'll keep going. I'm gonna run through the screens as best as I can. Like doing these in person a lot more than online. Really don't like this is, I have the typical dog and pony show going through the screens, and it's mostly me talking, but I'd rather have you guys ask as many questions as possible. I got the Q&A thing going here, so if there's any questions you guys want to ask, it'll make it a lot more fun for me. And let's keep going. So go over some of the screens here. Goals, FRDA. I think I kind of covered that already. We're here to represent the lightweight insulating concrete industry. I mean, if you have a question regarding specifications or anything that has to do on a project you might be doing, we want to be as it says, or the go-to guy, but mainly we're here to represent the industry as it has to do with the building code. And I'm going to jump across the thing here just to make sure everybody knows what we're talking about a little bit better, because my family doesn't even know what lightweight insulating concrete is. So I'm going to jump across to this slide, and these lightweight insulating concrete roof decks are essentially what you're looking at here above this steel deck. We go over steel or concrete. You have a two-part combination of lightweight concrete and insulation board installed either in a configuration where the slope is in the structure, or when the slope is in the insulation and you have a flat deck with internal roof drains. The only reason we're in business is to provide slope and insulation. So this is kind of a cross section of what we're going to be talking about, and of a roof deck. So with that said, I'll swing it back to a couple of beginning slides, so at least you guys all know what we're talking about. We already talked about this a little bit. I didn't even see the slide there, but I guess I didn't need it. We'll keep going, talking about the Florida Building Code. As far as I know, the Florida Building Code is probably the only building code in the United States that has a specific section designated for lightweight insulating concrete. We are under section 1917, which got reworded in one of the last, I think the last code cycle that we updated, it was 2017. We're maybe making some changes now by the end of the year, which we just discussed in our board meeting last week. Lightweight insulating concrete, chapter 1917, also works very closely with chapter 15, which is the roofing code. I should have said this earlier. The lightweight insulating concrete system is a roof deck insulation, but it has to work very closely and in conjunction with the roofing system. It's very important. Every job that we install, we have to know what we're going over, be it the concrete deck or the metal deck, which I just showed in the slide that I jumped ahead to. And we have to know what's going on with the roofing membrane that's going on top of us, whether it's a TPO, modified, built up, or whatever. It all has to match when it comes to wind uplift and product approvals and the Florida Building Code. See, we'll keep going here. All right, this is something that just got introduced, well, I guess 4 years ago, regarding electrical conduits on the roof. The association passed this. And with that said, a lot of times we'll come up on a project where we're going to pour a roof deck, a lightweight roof deck, first slope at R value, and then you're going to find electrical conduits running on top of the substrate that we're supposed to put down. In order to, in the interest of life safety down the line, well, here's what happens. The general contractor, they may have made a mistake or something because it wasn't designed like this. They come ahead and then to fix their problem, they go ahead, if you see my mouse, they lay out these electrical conduits all over the roof, running from their AC stands or any electrical, runs that they have on the roof. Then they expect the lightweight insulating concrete to bury these pipes, which lightweight insulating concrete really does a good job burying it, but the Florida Building Commission thought it was important enough to put it into the 2020 building code that you would not be allowed to bury it anymore because of a life safety. I mean, these are live electrical lines. You bury it in the lightweight. Once it's done, it's a nice finished, clean roof. 10, 15 years down the line, they come to do an alteration or something. They start cutting. Now you could have a potential issue where someone can get hurt. So in the building code, this cannot happen. These guys have to be designed up front, either installed in the actual slab itself, where it's in the actual concrete deck part of the structure, or beneath the roof deck below. Some more pictures of what we're talking about. Okay, that's what we got for that. The definition of lightweight insulating concrete, Florida Building Code 1917 has a specific definition for it, and it's what it says right there. It's essentially it's without reading the definition, it's concrete, basically concrete with air. It's concrete with air or with an aggregate, which is a very light rock. That's, I'm going to call it the old school way of doing it. Some people might disagree, but I'll go with that. And it's essentially, it's a concrete with air or aggregate added to it that it will not weigh any more than 50 pounds a cubic foot. We'll get into the weight, the actual weight per square foot of the lightweight in a second. Oh, I see some questions here. Is this system similar to IRMA roof? Yeah, I'm not really following what an IRMA roof is. Maybe it's too early, my brain's not working. So Jim, if you could expand on that. And Miriam put a question here about the conduits. The conduits above the slab will interfere with the water drainage. Is that not a problem with the solution? All right, so good question. So you have the pipes on top of the slab, right? Yeah, it would be a problem with drainage, but if you can see, here's a picture of the pipes on the slab, and you have a drain. The lightweight insulating concrete, I'll go back ahead to the slide ahead. Let me find another slide. When we put the lightweight insulating concrete over a concrete deck, bear with me, I'm going to just jump ahead to another slide. When you pour the lightweight insulating concrete on top of a concrete slab, you see this little thin layer here. This is called the slurry coat. So let me just kind of break down how the installation goes. You have your concrete slab, like you saw in the picture. The way you go ahead. I see another question there, William. I'll get to that in a second. You have your concrete slab. Pour 1/8 of an inch or so of the actual lightweight insulating concrete. Then you stick, while this concrete down here is still wet, you go ahead and you stick down these insulation boards in the configuration needed. These styrofoam boards, you install them in the configuration needed to give the proper slope and insulation value to the roof. And then you cover it with a minimum of 2 inches on top of the concrete. Imagine you guys can see my little cursor thing going here. So the whole thing with the pipes is you cannot do that anymore, which you used to, but you can't. When you have the pipes laying on top of this concrete deck, the lightweight insulating concrete was a solution where, when you're pouring this initial slurry coat, let me go back to that slide, you would then bury these pipes. So these pipes would be buried in the bottom of the lightweight insulating concrete system. So I hope they're not going to they're not going to do anything to the slope, because the slope's going to happen on top of that. I hope that answers the question. Willem, you put a question here. Do you recommend adding moisture barrier additives? I guess when you talk about the moisture barrier additives, that would be to protect the inside of the building. That would be for the inside of the building to protect the water out. We do have approvals to go over existing roof membranes, or you can actually put down a moisture barrier or a temporary roof membrane down before you pour the lightweight to maybe, in other words, you could put the moisture barrier down, keep the building dry inside, then pour the lightweight on top of it, making sure everything will be 100% dry inside. That happens a lot in re-roofing applications, not really necessary in new construction, as the building inside is under construction. Again, you put a comment here. Can we use that for ICC 500 buildings such as Emergency Operations Center? Absolutely. I mean, this product will go on any building where you have a flat roof. As far as wind uplift approvals, which is a very important part of the of an emergency operations center, right? You want to make sure that it stays intact if a hurricane's coming. You want to make sure that it's meeting the uplift pressures that you have, and we'll share with you later how this material has probably the highest uplift pressures of any roofing products in the industry. Okay, keep going through the okay, Richard, I see you put a slide here. Question: does the lightweight concrete want to crack where the foam changes in height in your drawing? Not necessarily. I'll kind of touch on that a little bit later on when we get to those slides. Okay. Types of lightweight insulating concrete. Let's keep going with it. Okay, we have the cellular and we have the aggregate based, like I was kind of mentioning earlier. Cellular is cement, water, and air. And then aggregate is cement, water, and aggregate. I'm going to recall the aggregate base, kind of the old school way of doing it. That takes a lot more labor and a lot more resources to put that into the mix. Let's get rid of this. The way the process is going, to do the air, you literally get something like a shaving cream. You get some shaving cream that goes ahead and you get, you know what, this is the next screen. So you see, Adolfo, you put a question there. I'm going to take the recommendation of someone here. Can the questions be answered later, if not addressed in the presentation? I'm going to go ahead and kind of shift gears, and I'm going to go ahead and answer all the questions towards the end. I think it'll give a little bit better of a flow. I'd rather do this in person, but here we are. Anyways, for the cellular concrete, all right, which is the kind of the new technology, so to speak, of the lightweight insulating concrete, you get a preformed foam, which is more or less kind of, imagine a shaving cream, if anybody uses that anymore, the old school, that's just a white foam that comes out of the can. You get the initial concentrate of what makes the lightweight insulating concrete. You dilute it with water, it makes the foam. You mix that with the cement and water, and it produces the lightweight insulating concrete. Kind of the same idea with the aggregate. Instead of putting the foam, you're putting the aggregate, which is the rock, which is which is just another, it's another rock, it's another aggregate. You're getting your cement, your water, and your aggregate, and you're putting it into the mix. And then you go to work. To put this in, you physically have to put it into the mixer. This costs way more than the air. I don't know about you guys, but the air that I'm breathing right now is basically free. Go figure. This, when you do the cellular mix, the preformed foam goes ahead and creates these tiny air bubbles in it that fills the lightweight concrete up with air. And that's what gives it the lightweight concrete properties. It's basically concrete with air. This is typically going to be the less expensive one of the two. This one does have its benefits, the aggregate, because it would be used better when you have really hard slopes that you see every once in a while. But apples to apples, the cellular is typically the one that's probably used 95% of the time. Some people might come in the industry and say that the aggregate's better because you get stronger PSIs, et cetera, et cetera. If anything, let's just let this presentation clarify one thing. It doesn't matter if you're doing cellular or you're doing aggregate. You're trying to achieve a compressive strength. And as we talked about earlier, the lightweight insulating concrete by definition is a material that doesn't weigh any more than 50 pounds a cubic foot. Whether you do centimeter or aggregate, you can achieve the PSIs that you want, and PSI is PSI, and typically you're going to be at around 300 PSI. Okay, talked about this earlier. We said earlier that the weight of the lightweight insulating concrete is no more than 50 pounds a cubic foot. A lot of times we'll get in on projects where people are going to say, well, the lightweight insulating concrete, does it weigh too much? I can't do it. As opposed to the tapered insulation, which is the alternative roofing product. The lightweight concrete is going to weigh too much. Well, but then when we break it down, people are thinking that the lightweight insulating concrete is going to weigh structural lightweight and regular structural concrete weight. As you can see, lightweight insulating concrete weighs about 50 pounds, no more than 50 pounds a cubic foot, or structural lightweight concrete up to 115 pounds a cubic foot, and regular strength concrete up to about 140 pounds a cubic foot. Lightweight is going to weigh about 20% of what regular strength concrete weighs. When you break that down per square foot on a building, on an application, when you're doing a lightweight system, you're going to weigh more or less, finished product about 11 pounds per square foot, as opposed to the other products. So when you're specifying, if anybody offers you a lightweight insulating concrete solution for your project, call us if you're worried about the weight, and we can definitely help you clarify that a lot easier. Okay, we're going to talk a little bit about the insulation board that goes inside the lightweight insulating concrete. This is essentially a styrofoam product that gets installed. We have all the ASTMs and code regulations and everything that we got to meet. Everybody knows what they're supposed to follow. These are individual, basically rigid insulation panels. They usually come in 2x4 foot sheets. And they're installed in the mix. And this is where the majority of the insulation in your system comes out of. Everybody, the way that that lightweight insulating concrete provides a insulation property and R value on the project is to give a total system R value on the job, meaning that it's including the air films, roof membrane, board, concrete, and it's a total system R value that we're giving. That's where this is where the styrofoam board is where the majority of the insulation comes from. You see these little darker circles here. What these are is in the panel, looking at it from the top to bottom, you have these holes that are spread out throughout the board that enables you to connect the top pour of the concrete to the bottom pour of the concrete in the mix. Like you can see it here in the next slide. You have your substrate, be it metal deck or concrete. You could go ahead and come in, pour the lightweight insulating concrete down all over the substrate. And the initial coat that you're looking at there is what's called the slurry coat or the bond coat. While this material is still wet, this insulation board, looking at it from the top, will get installed in the configuration needed to provide the slope and R value. Once this board sets on top of this slurry coat, you come in and you pour minimum, most approvals are minimum 2 inches of lightweight insulating concrete on top of the board. While you're pouring the concrete up here, the concrete's pouring through those holes, through the holes on the top. See them there. While you're pouring the concrete on top, the concrete is getting installed and poured through the holes, locking in the top layer to the bottom layer. And then that's basically, once this dries up, this is you have to let this dry to be ready for the final roofing application. Because remember, we have to worry about what we're going over, and we have to worry about what goes on top of us. It's very important. Somebody put a question here: does the lightweight concrete want to crack where the foam changes height in your drawing? No, that's really never an issue for the lightweight concrete cracking right here, because there's enough material in there that Richard, that'll protect it. It won't necessarily crack where the board is connecting, because they're really abutted very tightly together. There will be surface cracks throughout the whole lightweight insulating concrete. An old joke that the founder of our company used to say is that you get those for free. When you buy the lightweight, you're buying, you get that. We'll throw in the cracks for free for you. the cracks that you're going to see on top of the deck are not they don't do anything to the system. They don't harm the system. They actually help the system, because that is where the majority of the water dries out. Remember, this is a concrete application, so you have a lot of water to put it up there. So in concrete, there's a lot of free water that needs to evaporate. So you have to go ahead and let it dry before the roof membrane goes down. You never want to roof over a wet deck. You're going to have all kinds of issues, and obviously nobody wants water inside their building. So with that said, you will see superficial surface cracks, and really cool way, a really neat thing that happens with this is that's how you're going to tell also that the deck is dry. After you pour your deck, you got to wait usually typically 3 to 5 days to start roofing, as long as the weather conditions outside are okay for that. With that said, you're going to notice that the cracks are going to have a much darker gray color than the rest of the lightweight insulating concrete deck. Reason you're having the darker gray color is because that's where the water's coming out of, and that's where it's wet. So if you're seeing a dark gray color anywhere on the deck, especially on the cracks, you know that it's not time to roof yet. You want to make sure that the whole deck, including the cracks, have a light gray finish, and you're ready to go. I see a couple interesting questions here. Dean, you put a question here. How far back from the drain do you have to hold the EPS? Very good question. This is just a standard detail that shows the EPS starting back here. The layout of the thickness of the EPS is going to depend on two things: slope and R value, like I've been saying. 99% of the time we're installing it at a we're installing the lightweight insulating concrete system at a 1/4 inch slope. Reason it's a 1/4 inch slope because that's what the building code says. Any new construction has to have minimum 1/4 inch per foot slope on a roof, on a flat roof. Re-roof applications are a little bit different. They just, I believe the code just says positive drainage. It might just say an 1/8 inch, but I do know we do an 1/8 inch from time to time when we have a re-roof application. But the EPS can actually go right up to the drain. As a matter of fact, depending on the type of the building that you're designing, you want to have the EPS. Actually, the thickness of the board, I guess this is a good time to talk about R value. I think it comes up later in the presentation, but we'll get into it. Talking about R value, insulation value for your building, there's always a lot of confusion. Architects a lot of times specify things leaves it a little bit ambiguous. A lot of times we'll see specifications that just say R19. R19 is the spec for the roof. Okay, well, what does that mean? R19 can mean average, which means the R value is spread out throughout the whole roof, or it could be minimum, meaning right here at the low point. My company, Cellucrete's company's position is, from what we understand from the Florida Energy Code, where, at least in my opinion, only God and whoever wrote the energy code can understand what it says. The energy, we understand from it, and we actually have a standard RFI that we send out, and we understand it to say that on any type of multi-residential building, which is a lot of what takes lightweight insulating concrete, on any multi-residential building, you need at least an R19 minimum. That means that you need R19 at the low point of the roof. This detail is not really complete because it's not showing a sump, but we'll go ahead and ensure that you want to make sure that you double check the code and your buildings when you're specifying it. But if it's an R19 minimum requirement that your project needs, you're going to have an R19. We always recommend it, and we always install it at the sump edge, which is the area before the drain where it really drops hard. The picture doesn't show it, but it's supposed to have a hard drop here to ensure that there's no ponding water around the drain. But to answer your question, yeah, the EPS board does go all the way to the drain. Typically, when it's an R19 minimum, you're going to have the R19 minimum about 1 foot out of the drain. Let's keep going. And Frank, you're asking about what R value you gain by adding the EPS board. Like I said earlier, the majority of the R value comes out of the EPS board. If it's an R19 minimum, it's going to be a combination R value between what's called the inside and outside air films, the roof membrane, the lightweight, the board, and the substrate. And it'll be a combined R value. And typically for an R19 minimum, it's going to be 4 inches of board and 2 inches of concrete. So that's what we're going with that. We kind of keep going through some of these slides and see what other exciting things we can come across. I see some more questions coming, and we'll go ahead and get to those later on, unless I see something that might have to do with what we're talking about. Here's another application where we don't see this so much anymore, but it still gets done, where the slope is in the structure, and you need the lightweight insulating concrete. Here, its primary purpose is for R value and to enhance the diaphragm of the building. Lightweight insulating concrete really does a number on enhancing the diaphragm, which could help maybe less steel that you can put on it. But here's just here's a drawing showing a cross section showing lightweight on a structurally sloped application. As far as the substrates, we're kind of touching on that a little bit. Lightweight insulating concrete will be installed normally over metal deck and concrete decks. And so somebody was talking about vapor barriers over existing membranes. We get calls a lot that can lightweight insulating concrete be installed over wood decks. It's kind of like it can, but it may not. Other parts of the country other than Florida, especially like California, they put lightweight insulating concrete over wood decks more frequently. Here in Florida, nobody has any product approvals to put lightweight insulating concrete over wood. The Florida market hasn't really doesn't really have many flat wood decks. That has really motivated anybody or made the necessity for anybody to test over wood decks. So concrete and metal deck, and usually concrete. Going through a couple more of the details of the substrates. Again, talking a little bit more of the metal roofing, of the metal roof deck. Like I said earlier, we have to worry about what we're going over. It's very important. In my company, we always do something called the technical spec review before we sign a contract. And that means that we double check the metal deck. We double check the type that's specified on the job. We double check the gauges of it to make sure that it meets with the product approval, that it's no less than a G90 finish. Because the Florida Building Code says it has to be a G90 finish, and the attachment patterns to make sure that you have a solid weld pattern and the right stitch fastening pattern. Okay. These are the typical metal decks that you see lightweight installed over. It's typically the metal deck that gets designed on the majority of the retail and commercial buildings that we go over top of. Type BV, wide rib, which means vented. We'll talk about that in a minute. Sorry. Type B is just a profile of the deck. And a lot of times you're also seeing type N deck, which is a 3-inch metal deck, which is apparently a bigger, stronger metal deck. As far as the whole vented thing goes, I don't know if you can see the little slots here. If anybody goes into a store with a metal deck that has lightweight, you could look up and see. Actually, I got a picture. Here it is. Here's a picture showing the hanger tab slots that make it a vented deck. A little bit of confusion in the industry when it comes to the whole venting of the metal deck. Does it have to have it? Does not have to have it? The Florida Building Code says that the lightweight insulating concrete, this is exactly what it says right here. It says lightweight insulating concrete shall be poured over bottom slotted steel deck as follows. Bah, 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 bah. But it also goes into saying in a later part that if you're going to install it over a non-vented substrate, concrete deck, or even a non-vented metal deck, if you have the right approvals, it has to be vented a different way. This venting of the metal deck was incorporated by the initial South Florida Roof Deck Association after Hurricane Andrew, that they put it in there to make sure that the metal decks get vented more, mainly as a safety cushion and insurance policy. Should water get trapped in the lightweight deck, it will always have a little bit more area to breathe and come out. But cellular concretes, which we talked about earlier, do not require a vented metal deck. They put it right on the manufacturers put it right on their literature. The aggregates apparently do, because they use a lot more water when you're going over a metal deck. Somebody's asking a question here. Do you recommend topside venting? Absolutely. It's actually part of the code that whenever you're putting a lightweight down, like I said, if you're putting a lightweight down over a non-vented deck, that you have to vent it another way. And I think the roofing manufacturer will put in vents. I believe it's one vent per every 1,000 square feet or something like that, but that's not a big deal. They put it in, and go to work. And then I just answered the question, should the metal deck be perforated? It's better if it is. If it's not that serious. John is talking about, please talk about vented metal deck moisture testing. I mean, sure. Like I said, the vented metal deck, not something you really need, but it's better to have it. Moisture testing, the main way to check that the lightweight insulating concrete is dry is that it has a light gray finish. There are moisture tests that companies could come out and do. It gets a little bit tricky when depending what time of year that you might be installing lightweight. Lightweight insulating concrete can hold up to 25% moisture. Our shirts, wood holds, I think it's 8 to 10% moisture just by being in the air in the highly humid environment that we live in South Florida. Okay, a couple of good questions here. How steep of a slope structure can lightweight insulating concrete be installed on? Kind of like I talked about earlier. We've installed cellular concrete with additives up to about 3-on-12. The aggregate-based lightweights, which is lightweight concrete made with the rock instead of the air, would be a better fit for a hard slope application. Because when you do it with aggregate, that's the one benefit that aggregate will have on a harder slope. You see that sometimes on schools because of the aggregate, because of the rock. It's not as a fluid material, so it'll hold up better in a harder mix. There are hybrid systems where we incorporate some of this to the cellular, but there you go. And should lightweight concrete be vented over a structural concrete deck? I mentioned that by code you have to vent it a different. A concrete deck is a non-vented metal deck. A concrete deck is a non-vented system. So you do have to vent it another way, which would be topside venting, as the Florida Building Code says. Richard, I see you put a question here. Can you install over tectum board? No, there are no approvals for it. If you're going to go over tectum board, you'd have to get it engineered with some. Well, you can if you get it engineered. And what do I mean by that? You get it engineered in a way out on the field with some type of on-site testing, where you'd want to probably have a moisture barrier on top of the tectum so the lightweight won't run through it. So you put a moisture barrier down on top of the tectum and then install it over that. And then that's how that would work. But lightweight typically doesn't get installed over tectum. Let me find out where I was at here. We were talking about the steel deck. We were on this slide about the venting. I think we talked about that. We talked about the different gauges. Talked about the G90 coatings. Here's a picture from probably 1980 something of somebody welding the metal deck down with a metal deck that doesn't even get installed with lightweight anymore, but you normally want to see a solid weld pattern when you're doing it. It's real. Most of the approvals, even for other roofing rigid insulation systems, are going to call for a solid weld pattern here, where it's every flute on the bar joist is getting an attachment. The side lap fasteners, it's important for us to know how many side lap fasteners per span are being installed. The reason we need to know that is because it says it right in our product approval. Here's an example of one of the manufacturer's product approvals where the maximum design pressure is 82.5. And if you come all the way over here to this side, it talks about the specifications of the metal deck. On this application, it's got to be 22 gauge. So it talks about the gauge, the type of the deck, type BV. That V means that it's got to be vented. G90 steel deck. That's the galvanized finish, welded to supports, max 6 foot on center. That was a big issue in the industry back in the 90s when people were building buildings with bar joist spacings much bigger than what the approvals were for. Mostly when you have a warehouse or a retail building that has a metal deck, the joist spacings are typically over 5 feet. Well, back in the day, all the approvals were at 5 foot on center, and you'd have buildings with 5'8", 5'9", 5'10" bar joist spacing. So that made everybody in the industry have to go out and get additional testing. So most of the tests are up now up to 6 foot joist spacing, which is how the buildings are designed. And it talks about how it is attached. Okay. I see some other questions there, which we'll get to at the end of the presentation. Okay, what happened here? So we were here. Here's a couple other examples. What happened here? Okay, so here's a couple other examples of the product approvals, and you got to be careful because some people got lucky with the building department and didn't get so much detail spec'd in it. Like you see this approval, I'm not sure which manufacturer this is. It probably doesn't exist anymore because this was expired a few years ago, but somebody was lazy that day when they issued this product approval, because as you can see, they don't even list, all they said was 18 to 22 gauge vented steel deck. Oh, I'm sorry, here it goes. It actually says it has more of the description here is a little bit different of a layout. But there you go. They're talking about all the different configurations, and this one has to be installed with Built-Tech fasteners instead of weld. So different configurations, different ways that it gets installed. Okay, let's keep going. Talking a little bit about the concrete slabs. I hope you guys see that these pictures are wrong because this should be coming all the way to the bottom, but we talked about it. Similar lightweight insulating concrete gets installed also on any type of concrete deck. It's interesting though, because we should be installed more on double T slabs, because double T slabs with their camber, you guys should know what I'm talking about. The double T slabs with the camber actually creates a negative slope on the high point of the roof. With that said, I don't have any pictures of it here, but with the double T slabs on what will be the high point of the roof, you're going to have less than a 1/4 inch per foot slope if you don't fill that in with extra material. But the lightweight insulating concrete would be a solution for that. Here's just what the approvals look like over a concrete deck. The lightweight insulating concrete uplifts are definitely a lot higher over a concrete slab than over a steel deck. And surprisingly enough, what I've seen as the highest uplift pressures are the lightweight insulating concrete when we're going over an existing membrane over a concrete slab, this is supposed to be a temporary roof membrane down, and you can see it actually has a much higher uplift over the existing membrane than it does directly to the concrete. Let's finally show some pictures of what this looks like going down. And here's a building. This is a really neat picture. I want to say this building was called Millennium Tower. A lot of people ask me, whoa, how high can you pour lightweight insulating concrete? You can't get it up that high. This building was done probably sometime in the 90s, if I remember. I remember this job. It was Millennium Tower in Hollandale Beach. This building was around 350 feet up in the air. No problem. We pump it from the ground. There's definitely extra precautions that we got to take, but lightweight insulating concrete, our company's done it as high as almost 700 feet. I believe the highest building ever done with lightweight insulating concrete was the vehicle assembly building in Nassau. That was about 1,000 feet up in the air. Our company didn't do it. That was done by a company out of Central Florida many years ago, but you can definitely put lightweight quite high. This is a pretty and also neat picture because it shows the initial slurry coat being put down. Then you have the styrofoam being installed again in the configuration needed for slope and R value while this concrete is still wet. Okay. Here's a picture of the lightweight insulating concrete being installed on top of the board. The picture's a little bit off, but you get the picture. There's the drain. Somebody was asking if you could put the board all the way up to the drain. As you can see in this project, the board was installed all the way to the drain. Interesting here, a precaution that our company takes is that this is actually a picture of one of our guys. That's Max. He doesn't work here anymore, but I don't know where he's at. This is a while ago. You can see that the drain is actually covered to prevent any lightweight going down the drain of a 35-story building. You imagine what would happen if we filled that drain up? It's happened before. Not pretty, but we do take the precautions and cover the drains. And there you go. Quality control. This is the way that it gets measured on the roof to check the density. And it's important to make sure that we're getting the proper 2-inch thickness of lightweight insulating concrete on the roof. Some more pictures of the deck being finished nice and smooth with the screed bar to the drains covered. And let's go to work there. I hate this picture because it says finished roof, ready for memory. This roof is not ready for roofing membrane, never in a million years. You can see the dark gray color. This slide is there, but it's, you can see a lighter gray finish is getting closer here, but all this dark color here means it's not ready for roofing yet. But you guys get what I'm saying. And here's a picture probably from the 70s, somewhere up north of a finish. Actually, no, sorry, from 1994. Look at that. When we had cameras that weren't digital. What the roof looks like finished. Recovering. This picture's got to be from like the 70s, but here's just an example of the lightweight insulating concrete being installed over an existing roof membrane down to the drain. Some guys like to use fishing strings to make sure that you ensure the proper heights, but that's what you got there. The different roof coverings. We were talking about how we need to know what goes on top of us. Basically, every type of membrane goes installed over lightweight insulating concrete. You're built up, you're modified, you're single plies. Don't know why we say liquid applied there. I do not agree with that. Every time you put like liquid applied on top of a lightweight insulating concrete deck, it's going to be a problem. Do not do it. It will blister. It will not work. If anybody wants any more information on that, I'll be happy to share why, but I don't care what this thing says. This is wrong. Do not install liquid applied over lightweight insulating concrete. It will fail. It's happened every time we've done it. Normally, what we see installed over lightweight insulating concrete these days are single ply, either fleeced or smoothback. Has to do with pricing and the right product approvals that exist over lightweight. And probably 90%, 95% of what we install are single ply roofs over our lightweight systems. When you're doing a modified system, insulating concrete, roof decks are versatile substrates. Yeah, we're talking about. Now we're talking a little bit about the membrane attachments. These are the different type of fasteners when you're using a modified base sheet where you're nailing the initial layer down to the lightweight and then going on top of that. Okay. As far as fire rating goes, okay, let's go here. What did I do here? So as far as fire rating goes, lightweight insulating concrete pretty much meets any fire rating that you need for your buildings. We have all the UL and FM fire ratings that you need. If you look at the UL assemblies, if you've read them all, there's a million of them. There are different configurations. Somebody was asking a question here. Okay, Mark Beatty. That Mark Beatty, that's not the Mark Beatty that I've known for a long time. I think it is. Hope you're doing well, sir. You put a question here, Frank, do you recommend crack control of the top layer of the lightweight? Example, chicken wire. So this slide is showing the chicken wire. No, we do not recommend chicken wire on top of it. You can, if you can find it. In the 30 years that I've been doing lightweight insulating, that I've been working here, we probably do 150 to 200 jobs a year. I've maybe done wire mesh 3 to 5 times in 30 years. The only reason that you would need wire mesh in a lightweight insulating concrete application is to achieve a 2-hour fire rating over a steel deck. It's rare that they need it because they're usually getting the fire rating a different way. And it's just not necessary for uplift, and it's not going to really do much. It's just nobody has any approvals and you don't need it. And honestly, I think the only company in the country out of Louisiana that made it went out of business. So, but yes, you could achieve any. These are like I said, probably $1.5 million uplift, $1.5 million fire ratings that have to do with lightweight insulating concrete on steel and concrete decks. Never found a project where we haven't met the fire rating. So if you have any questions about it, if the lightweight will meet a certain fire rating and how we would meet it, we're happy to help with that. Okay. We'll keep running through a couple of the different slides, talking about roof uplift. These are kind of old pictures, but probably hits home to a lot of us here in freaking Florida. This is the one that started all the changes. Hurricane Andrew in 1992. Bad, not good. They just keep getting more fun now, right? Some of the destruction that Hurricane Andrew did. Pretty crazy stuff. This is actually a building in Louisiana that everybody forgets that Andrew went that way. This picture was on the cover, I believe it was the USA Today newspaper. People still use newspapers back in the 90s. This was the building called Saga Bay, where you can see the whole facade fell off the building. See the concrete slab right here. And then this part right here is the lightweight insulating concrete roof deck that stayed unharmed over the deck. What happened was that the roof membrane peeled off. This was actually an aggregate based lightweight deck, the one that doesn't really get installed that too much anymore because it's the old school. Our company actually got hired to go out there, recertify the deck, and they ended up reusing this. This feels like it was a long time ago, but yeah, wow, in 2004, I'm sure a lot of us remember these 4 stupid hurricanes that came right through Central Florida and messed up a lot. But happy to report that as far as our companies goes and a lot of the other manufacturers go, the lightweight insulating concrete did not have any damages when it was faced with the buildings. I mean, when it was meant to stay down, it stayed down. Here's some pictures of buildings all across Florida that didn't have any damages. I know we just had a couple other hurricanes. I don't know of any buildings that have sustained damages with lightweight. This was after Hurricane Irma. I think it was 2017, if I'm not mistaken. All across Florida, no real damages. Here's some damages that happened with the rigid insulation systems that went down. Lightweight insulating concrete, like I said, has a bunch of different uplift approvals. This was a report published by the University of Miami, Dr. Ron Zolo, comparing lightweight insulating concrete to rigid insulation and saying of the two metal deck over bar joist systems observed, the systems using lightweight perform best compared to other systems. So I know we'll hold up against the wind. EHPA, this was introduced, enhanced hurricane protection areas. This was introduced for the school board in Central Florida to just ensure that the buildings are going to hold, that the roofs are going to hold the impacts of missile impacts and things flying on the roof. Lightweight insulating concrete has all the ratings that you need from that. Talked a little bit earlier about diaphragm. I'm running out of time, so I will go through the last couple of slides. Talking about moisture absorbance and transfer, how the lightweight insulating concrete does not transfer moisture in the deck. Rigid insulation, which is the alternative product with the fasteners that go through it, will have a lot more loss of R value. Didn't really dive into it, but here's a pretty neat picture. No, this is not EPS board. This is actually a picture taken, I believe it was in Canada, in the winter, of a rigid insulation deck where the rigid insulation is beneath the roofing membrane. And what you're seeing here is the heat transfer of the roofing fasteners and plates that go from the rooftop down to the bottom. Remember, this is in Canada. Moisture is going to diffuse. Moisture will diffuse upward here, and that's why you're seeing the melting of the snow directly on top of the fasteners. These are all the gaps in the rigid insulation panels, and those are the screws and plates showing how the moisture transfer happens in the rigid insulation. Do gaps occur? When people talk about cracks, rigid insulation panels, it's normal for them to have up to a quarter inch gap in their installations. Isoboard does shrink 2% over time. And this is showing what the gaps will be, which will be loss of R value. Some slides that show some more information about loss of R value. Okay, we're not gonna spend too much time on it because we're running out of time. And here's just some pictures that we've done all over Florida by lightweight applicators. Now, the Amway Center, Performing Arts Center, this is actually a neat building that we did that had some hard slopes, and we were able to get that done. Here's a picture of the Epcot and the Living Seas. Pretty neat how lightweight insulating concrete is on that roof on a harder pitch. Big warehouse, Embassy Suites Orlando. This is the building I was talking about, Met 2 Miami, that my company did. That was almost 700 feet up in the air. Q&A, let's go here. These are some of the members of the association, and I got a few minutes to go over the questions. Okay, Thomas Lee, you asked, do you believe the code changed because the conduits were surfacing above the thickness of the concrete topping, causing failures in topping situations where the membrane was actually adhered? No, the code changed because life safety, to save somebody's life. The conduits were installed on top of the concrete slab. Lightweight insulating concrete goes ahead and buries all of that. The lightweight insulating concrete will bury it, and just for a life safety issue, and you'll never see the conduits after they're poured. Somebody goes in there to cut the roof, could have a life safety issue. They could get electrocuted. So that was the main way that happened. Maged, I think I'm saying your name correct. You said, so there is no tapered panels and need to move from thickness to other than the 1 inch difference. There are no tapered panels in the lightweight concrete. There are EPS panels, which are board panels that are installed in the stair-step fashion, as you saw in the previous slide. That goes ahead and, again, it's a stair-step pattern. Jump back to it. It's a stair-step configuration. You know, let's say this is a 1-inch board, a 2-inch board, a 3-inch board, installed in the configuration to give a 1/4-inch slope. The finished product is a tapered application where it's a finished tapered roof surface. Samuel, you put minimum 1-inch if poured over existing roof. Typically, it's a minimum of 2 inches over the top of the board. I would imagine if you're saying over existing roof, if we're going over an existing roof membrane, let me go to that picture from the 70s. Where is it? If you're pouring over an existing roof, a lot of times you're going to still have some of the gravel still stuck on the existing roof. This existing roof will require a little bit thicker of a slurry coat. This picture does not appear to be a 2-inch pour there, but whatever. When you're pouring the slurry coat over a roof substrate like this, that there's more, you know, I guess just obstructions and it's just not a smooth surface, it will be more than an 1/8 or a 1/4-inch slurry coat. It'll probably be closer to an inch slurry coat. Jorge, you say what methods are used to ensure proper thicknesses is maintained throughout the installation? Believe it or not, the guys have measures on their boots, believe it or not. They do randomly check the thicknesses on top of the board on their boots. Believe it or not, they're 2 inches, and that's what they use. If it's a cut up roof, a lot of times they actually use screed bars, which is my favorite because that's make sure that you're not giving less and you're not giving more. We're giving what we're supposed to give. So screed bars, and believe it or not, they're boots. Corey Schultz, you said, do you have any damage data relative to tornadoes associated with hurricanes? It's funny whenever there's a hurricane that comes through, everybody becomes an expert. Nobody likes to admit that their roofs got damaged. We really don't have anything specific about a tornado, but every time we went on a roof, anytime I go on a roof after a hurricane, that something happened to the roof, not the lightweight insulating concrete, but the roof membrane, everybody's an expert saying, well, that was a tornado that had to come through here because there was no way that, you know, no one's going to ever admit where they messed up. Everybody says it's a tornado that messed it up. But I know during Hurricane Andrew, our company had, I think it was 86 decks installed. Creed had 86 decks installed in the path of Hurricane Andrew, and we did not have one reported failure. I do remember the story of down, I believe it was Cutler Bay. There was a Sears and a J.C. Penney's. The Sears had I don't know if people still know what a Sears is, but anyways, the Sears had a lightweight roof deck on that building, and the J.C. Penney's had a rigid insulation. The Sears building was opened up the next day after the storm, selling generators to the J.C. Penney people. So that was kind of neat. And Richard Logan, can you pour? Oh, Richard Logan. Oh, nice to see you. Can you pour lightweight over polyiso? No, you cannot polyiso. Once it gets wet, it's done. Instead of polyiso, that's why you use the EPS board, which can hold up to the moisture in the lightweight without a problem. You are either installing a polyiso roof, or you are either installing a polyiso roof, or you're either installing a lightweight insulating concrete system. Let me go here, 1 second. Someone's asking me to share my contact, so let me see if I can find it. There it is. Where is my contact? This would be my contact information. If you'd like to get it, just call me on my cell phone or my email. So that's what we've got there. What is the cost premium using lightweight insulating concrete versus insulation board? What is the cost premium using lightweight insulating concrete roof versus insulating board? Remember, okay, so lightweight insulating concrete, when you're installing lightweight over a structurally sloped, I hope you got my contact information. I left it up there long enough. Let me go back to the slide to answer the question. So when you're installing lightweight insulating concrete in an application like this, where the slope is when you're installing lightweight insulating concrete where the slope is in the lightweight insulating concrete or in the roof insulation, this is going to be 30 to 40% probably less expensive than rigid insulation. If you have a flat roof that the slope needs to be in the insulation, whether it's lightweight or polyiso, go with the lightweight. It's going to be a lot less expensive and it's going to be a stronger roof. The way we've always sold it, and some people you probably won't know what this means, is when you're getting the lightweight insulating concrete, you're getting the Cadillac for the price of a Yugo. For the younger generation, you're getting a G-Wagon for the price of a Corolla. That makes sense when you go with a lightweight insulating concrete system. Kenneth, you're asking, can lightweight be used below a flat amenity deck where concrete or wood pavers are supposed to be on a pedestal system? Lightweight insulated concrete is very strong. You can walk on it. You can park. I mean, we have our tankers parked on it outside in the yard. What happens, Kenneth, is the product approvals, the assembly that you're going with. You can use it on an amenity deck where there's concrete or wood pavers, but the question is, what is the waterproofing system that you're going to be installing on it? How does all of that fit? So if you have a pedestal system that you want to use the lightweight, we can help you. And maybe it's a pedestal system where you have a roof membrane. It's the approvals have to match up. I think, Wendy, it's 8:58. How am I doing on time? I think you want me to stop.
Yeah, actually, yeah. Your presentation ends at 9, so right on time.
Good deal. Had to rush it a little bit there. I don't want you to yell at me. So I kind of sped up a couple parts there, but I see like there's 12 things on the chat. Is that something I'm supposed to look at too?
There is a lot of questions about to staff about surveys and attendance and things like that. So staff is monitoring those. I'm trying to, I don't.
Leland is asking, will the video be made available? You guys said within 10 days. I think I paid attention to the first part.
Yes, exactly. Yes. So we can manage those questions. All right. Well, if that's everything, just a couple reminders that the presentation material that you're seeing is available in the resources tab. So if you guys missed anything, you can refer back to the presentation material. And like Frank said, there's contact information, even better. So again, if you missed that, no worries. You can get it in the resources. And then these recordings will be available on our webinars page in a couple weeks.
There's my contact info also.